Welcome back to Sports Science Supplement, and today we are doing a quick revision over linear motion. And we're going to introduce you to all the terminology involved with linear motion and why it's important to coaches and performance analysts. So mass, that is everything your body is made of, and we use kilograms to measure that. Inertia, resistance of the body to change its state of motion. Okay, so this goes all the way back to Galileo. If the ball is on the penalty spot, okay, it will stay there until it is kicked or an external force impacts that body. Distance, this is the path taken in moving from the first position to the second. This is usually measured in meters. Likewise, displacement measured in meters. This is the shortest and straightest route between the first position and the second. Okay, I tend to think this as the crow flies. Momentum, this is the amount of motion possessed of a moving body. This is given by mass times velocity, hence why we have kilograms per second. Speed, this is the movement per unit of time with no reference to direction, so I'll come to that in a little second, okay, but hence why it's meters per second. Velocity, this is the speed of a body with a direction, and likewise we give this in meters per second. Acceleration is the rate of increase of velocity in meters per second squared, and hence deceleration is the other aspect of it, is negative acceleration, so you're slowing down. Zero acceleration, obviously you're moving with constant velocity, so acceleration is zero. This does not mean that your actual velocity is zero. Okay, you could have an actual velocity of 10 meters per second as a jog, but your acceleration is zero because you are staying at 10 meters per second. You're not increasing or decreasing, you're not accelerating or decelerating. Weight, okay, this is mass times acceleration due to gravity. This is measured in newtons. Please do not get this mixed up with your mass. Okay, weight is your actual mass yourself and the effect of gravity on that body. For example, if you're on Jupiter, you would be a lot heavier. Reaction, okay, this is the equal and opposite force. Okay, also because it's a force, it's given in newtons. Again, another force, friction, the force that opposes motion of two surfaces in contact. This usually goes in the opposite direction to the force. If you can give a sporting example when that would occur and not oppose motion, this would really help your revision. Okay, I'll give you one example. If you go with Usain Bolt and the sprint start, okay, the friction force is going in the same direction as motion. Can you give another? Air resistance, this force opposes motion. So if you think about a parachutist, okay, it depends on the shape or streamlining effect of that body. The surface characteristics, i.e. like a golf ball, if you've got those little dimples, okay, they create pockets of air and in fact actually make it less air resistant and therefore travel a lot further. However, if a golf ball is completely smoothed off, it would not travel as far. True fact, please look that up and research. Very interesting. Cross-sectional area, okay, again, if you had a very obese individual versus a very thin individual for a 40-meter dash, okay, the very thin individual will probably win more likely despite strength because of the amount of air resistance that might occur. Okay, and velocity, like I said in a previous video, you put your hand out the window of a moving car, you're more likely to feel that resistance against your arm, that the wind hitting your arm, than you are if you're just running along. Okay, that force will be a lot higher. Resistance or drag experienced by an athlete would depend hugely on the fluid environment. Again, if you're in a pool, okay, that would be greater drag than you were to be running along the street. Okay. If you're interested, okay, this article came out in 2011 by De Broglie and colleagues. It's very good. Basically, it talks about how you need about 90% of force output, so 90% of your effort at 14 meters per second to overcome air resistance. And that is absolutely astounding, how much effort you need to put in to overcome that force. Scalar and vector, okay, so we're talking earlier about. So particularly with speed, it's scalar quantity, okay, because it tells you the magnitude, like the size of the force or the direction, but not the direction, okay. So a London Marathon runner runs a distance of 42 kilometers. There's no indication of which direction they ran, okay. It could have been anti-clockwise or clockwise. That it doesn't actually say. However, vector quantity is something that gives you both size and direction, so magnitude and direction of a force or movement. So displacement, okay, I'll come to that in a very minute. I've got a very good exam question for you all. A London Marathon runs a displacement of 10 kilometers in a northwest direction, so a direction has been given, so therefore it is a vector quantity. Okay, here's the practice exam question. A 400-meter sprinter completes a race in first position. Calculate the athlete's distance and displacement travelled. This is a very simple question that examiners like to give at the beginning of the exam. Okay, I would like you to have a go at answering this. Okay, so obviously a 400-meter sprinter doesn't sprint in a straight line because the track's not completely straight. So they run in that oval shape, okay, around the track. So the distance they travelled from the very beginning to the very end, so the route they had taken was 400 meters because they stayed in that lane, which is equivalent to 400 meters. However, the displacement is 0 because technically they haven't gone anywhere. The start and the finish are the exact same place. Students get this very mixed up and they sometimes have trouble with these two descriptors here. And I think you need to understand these from the word go, because albeit it's 2 marks, these are very easily 2 marks that you could lose if you do not understand the difference between distance and displacement. So distance is the route, displacement is as the crow flies, okay, from the very beginning to the very end of the route. How far have you travelled? I hope this makes sense. Please give it a like and good luck with your revision and your exams.